ओके सो आपण ॲब्रप्टली स्ट्रीम बंद केली अँड विल कंटिन्यू फ्रॉम वेअर वी लेफ्ट ऑफ ऑर विल जस्ट स्टार्ट फ्रॉम एनी न्यू व्हिडिओ. आत्तापर्यंत आपल्याला मेन गोष्टी या कळल्यात की कॉन्ट्रॅक्टमध्ये आपण सेपरेट रॉयल्टीचा पार्ट ॲड करू शकतो विच इज आय थिंक ट्रान्झॅक्शन फी अमाऊंट. विल चेक दॅट अगेन बट या आय मीन नॉर्मल कोडमध्ये जो हा कोड होता याच्यामध्ये देर इज नो रॉयल्टी ॲज सच आणि जो दुसरा आहे त्याच्यामध्ये रॉयल्टी ॲड केलेली आहे. अँड विल कंटिन्यू टू लुक फॉर सम अदर ऑप्शन्स. क्रिएट युअर NFT नाही, हा मोठा आहे, आपण याचा ऐकत होतो. आणि हे थोडंसं हे कॉम्प्लेक्स होऊ शकतं सुरुवातीला, सो विल स्किप दिस फॉर नाव. लेट्स गो टू सम अदर ट्युटोरियल. ॲक्च्युली हॅशलिप चा एक चांगला व्हिडिओ होता हॅशलिप. सो लेट्स सी क्रिएटिंग 10,000 मिंटिंग. या दिस वॉज अ गुड वन. अल्टिमेट गाईड हे पूर्ण 2-2.5 तासांचं आहे. लेट्स सी, विल जस्ट फास्ट फॉरवर्ड थ्रू दिस.
In this video, I'm going to show you how you can create your own collection on OpenSea, have your own smart contract of your collection on Polygon and Ethereum, as well as a minting dApp in 3 very easy steps. My name's Daniel, aka Hashlips, and welcome to the channel. I am going to show you the whole process of uploading your collection onto the blockchain, Polygon and Ethereum this time. The reason why I'm making this long video, this continuous video all in one, is because I want this to be the ultimate guide for people who are struggling. This will be beneficial for people who have already tried out this process and for the new people who want to actually go ahead and create their collection from scratch. I've made it very easy by creating 3 packages that you are going to be using. I call it the 3O. If you follow these 3 packages, you should be good to go to just upload your collection onto the blockchain. I want to make a disclaimer though, everything I show you in these videos are all for educational purposes. So please review the code carefully before using it for production. I will not be held liable for anything you upload on the blockchain. That being said, I am using all these repos for my own project. Let's jump in and let me show you how this is done. I am very excited for this video, and mainly because it's going to help so many people in the future. Now let's get started. If you head over to the Hashlips GitHub repos, you will find the repositories, the 3 main ones that we will be using. The 3 ones are called the Hashlips Art Engine, then the Hashlips NFT Minting dApp. How we create a bunch of these nerdy coder clones or pixel art or whatever you want to create, we need to use some kind of program, and this program has been designed specifically for people who want to take layers of different images and have a program randomly combine them with different rarities as well as export the metadata. This is exactly what this series is all about, is to start this process from scratch. But if you want an in-depth tutorial on the Hashlips Art Engine, you can head over to the YouTube channel, go into the playlists, and find this Create 1000 Generative NFT Artwork with Code series, this purple one over there. This series shows you from the start what to do. Now, you can watch that series, and this is how we start building up this actual repo. So I suggest watching it till the very end before starting with your repo. But if you want a brief overview and just follow along, you can do just this video as well. All right? Perfect. You'll see that each one of these repos has a nice description of what it does. This one takes layers and turns it into images, and there's a bunch of documentation that you can read through. Also on each of these repos, on the right-hand side, there's a release. The current version that we are at today for the Hashlips Art Engine is version 1.0.6. Always check the latest version and the updates and download this one and use it instead. But if there's a video that you see, I click on a specific version, rather go for that one, because it means that the code will stay the same if you do it over here. We'll download them in just a bit. The next piece of the puzzle would be this repo. This is the Hashlip NFT contract. Now the contract is something that we are going to deploy on the Ethereum or Polygon network. Now it takes code and it deploys it onto the blockchain in order for us to mint NFTs. And this is exactly what this repository does. I'll show you how to use it in just a second. Let's look at the third and final step that you'll be implementing. That is the Hashlabs NFT minting dApp. If you click on this one, you'll see that in the documentation, this basically takes the code that we have written for a website, a dApp, and it looks like this. You can see that the dApp behaves in a nice and special way where it connects to the smart contract that we have deployed. Then people can simply click on buy, and it will then start minting their NFT. You will have to have a MetaMask extension installed on your Chrome browser, and by having that, then you can start interacting with your smart contract, minting NFTs, and they will show up on OpenSea and start getting floor prices, volume traded, and a lot of owners. Now, those are the three main repos that we will be using. So I'm very excited. Let's get going. Our first step is to actually download each one of these files. So what you want to do is go into each one of these repositories, the Hashlabs Art Engine, click on the latest version, which is mine version 1.0.6 at the moment, go down and download this source code zip. So click on it to access the file systems. The installation and 1.17.6, it means that you've done it correctly. You can also check got version it that has more functionality. It colors the problem. Discord, the Telegram channel. Our Discord ask anyone appreciate to see a step in concept and start creating the layers for it. This is the Nerdy Coder Clones collection, and you can see that all these Coder clones looks different. Well, they were all individual layers. This is exactly what you'll need. You have to say new terminal up. That it has an edition size and a DNA. This is just to inform us which ones have been created.
सो रिअल क्विक या पर्टिक्युलर रिपॉझिटरीमध्ये त्याने काय केलंय की मल्टिपल 10,000 इमेजेस तुम्ही कसे रँडमली जनरेट करू शकाल की जिथे डोळे वेगळे आहेत, डोळ्यांचा रंग वेगळा आहे, केस वेगळे आहेत, स्टाईल वेगळी आहे, थोडीशी रंग वेगळा आहे. सो हे रँडमली चेंजेस करून प्रोबॅबिलिटी वगैरे सेट करून तुम्ही 10,000 इमेजेस स्क्रॅचपासून किंवा एका टेम्पलेटपासून कसे तयार करू शकतात त्याचा हा कोड आहे. So otherwise, the other option is to manually create 10,000 images, which is a time-consuming affair. So basically, याने बऱ्यापैकी ते automate केलं. So we are not interested in this right now. त्याच्यामुळे आपण याला skip करतोय थोडं. Fast forward करत करत पुढे जातोय.
To the /5 because it's now pointing to number 5.
So वेगळ्या
So we
JSON
can
files
verify
तयार
that
झाल्यात.
icon.
आणि एक JSON file will represent
Say
one.
upload, and this time I'm going to say I underscore hidden underscore image. Okay. Going to upload it like that. And then once this is uploaded, once this has refreshed, I'll be able to copy that CID. Make sure it's the hidden image that you've uploaded, CID. So then I can go back and populate this. But this time I need to say hidden.png. And to test this out, you first copy this. Okay, everything from the queue to that part. You copy this and you go back and you click on this eye icon and you go and replace everything. Once you have the gateway here, just replace it and call it. And there you can see we do get that image. So our metadata is pointing to the correct endpoint. So save this metadata file. Now you can go back to Vinata and upload another folder. This time it's going to be our hidden metadata folder. So it's going to... So this is all that we really need. Number 30.json, we can see this is the metadata. And indeed, there is our IPFS link like OpenSea wants us to point to the image. Even though the JSON is its own IPFS link, this points to the image alone. And that's all you need to do. Now, a lot of the NFT projects have hidden images. How do we accommodate for that? Well, that's pretty simple. What do I mean by saying hidden? Well, a lot of NFT projects kind of reveal the images only after the pre-sale or some kind of sale has ended, and that's when you can reveal the images, the real metadata, and that kind of creates some kind of excitement. How can we achieve that as well? Well, we have our real metadata and images up already, so now it's time to kind of image that will be here, right? Populate this data is going to be our final NFT. So I'm going to call it Eyes Smart Contract. Now our smart contract file. What we can do now is paste all of the content that we have copied from our contract. You'll see that a lot of artifacts get created. This is because all the dependencies have now been created in this one single file. Everything is in here. If you scroll to the very bottom, you'll see that starting from line, let me just go a bit up, starting from line 1235 is our smart contract. It's just called NFT. This is the very first thing that we are going to change. So if you are not used to Remix yet, maybe go and watch other tutorials where I'm working with Remix, where I have much more extensive explanations on Remix as a whole. I'm just going to show you the brief explanation of how to change the necessary things to have a successful collection launch. Go ahead and make the necessary changes. Starting with the name, I think we can change the name of the contract to Purple Eye, and it's also good convention to call the contract the same as what it's called in the file. So I'm going to stick with Purple Eye. Then in this section over here, these variables, this is kind of mostly where you need to update and customize this NFT contract to your need. For instance, I do not have to touch the base URI, this base extension really, and the cost I do need to change. So cost is basically how much it's going to be for someone to mint one of your NFTs. Now, keep in mind that we will be deploying on Polygon and Ethereum. So we would probably change the cost because the value of these two currencies are very different. But Ether will stay the same. Ether is simply a nicer way of appending a million zeros to convert Ether to Wei, okay? But Ether basically just makes it a nice readable way for us to write how much Ether this is going to be. I'm going to say that my eyes are going to be 0.0241. So I'm going to make that the price in Ether. And if I deploy on Polygon, which we will do, it's going to probably be a little bit higher. I'll probably make it like 5 Polygon, but we'll get there. So I'm going to leave this a bit higher. And if I deploy on Polygon, which we will do, it's going to probably be a little bit higher. I'll probably make it like 5 Polygon, but we'll get there. So I'm going to leave this at 0.02, and we have minted 50 NFTs. If we go back to Pinata, we can see that in our metadata, if we go and open this eye, we have
Okay, this is good. We can use Polygon USDC, which means की जो आपला पहिला प्रश्न होता की ओपन सी मध्ये ETH ब्रिज करावं लागेल इथेरियम वरून पॉलिगॉनला, तर आय थिंक वी कॅन जस्ट स्ट्रेट अवे USDC पॉलिगॉनवर जर आपल्याकडे असतील, विच इज इझी. सपोज USDC आपल्याकडे बायनान्स मध्ये पडलेत, तर बायनान्स मधून आपण ते विड्रॉ करू शकतो BNB चेनवर. सो USDC आपल्याकडे येतील बायनान्स BNB चेनवर. मग ते आपण ब्रिज करणार USDC टू पॉलिगॉन, आणि मग ते USDC पॉलिगॉन चेनवर आले ब्रिजिंग करून, त्या ब्रिजसाठी आपण पॉलिगॉनचा ब्रिज वापरू शकतो. अँड देन ते ऑटोमॅटिकली आपल्याला आपल्या वॅलेटमध्ये दिसतील. सो जेव्हा आपण आपल्या मेटामास्कला मॅटिक सेट करू, पॉलिगॉन सेट करू, तेव्हा तिथे आपल्याला USDC मध्ये आपली अमाऊंट दिसेल. सो आय थिंक दॅट इज गुड.
only 50 NFTs that's listed in here. They're not listed in order, but there's about 50 of them. So obviously I want to keep my collection to 50. So this is the max supply, which I'll change to 50. Now, if you have a big collection, like obviously 50 is a quite small collection, this max mint amount is the maximum amount that a person can mint per session. For instance, if they call the mint function, they can mint up to 20 NFTs if it's left at 20. But seeing that I only have a max supply of 50, I'm going to say people can mint a maximum of 2. That sounds reasonable. Now, this paused variable determines if your contract is paused. If a contract is paused, not the owner or anyone else can mint. But if someone has already minted, they can freely still use the contract, send the NFTs around because it's their NFT. It simply just pauses the minting functionality. Usually you would start off by having pause set to true. And the reason for that is because you might want to deploy your contract and only set it to true once you have maybe made the announcement that everyone can start minting. So maybe a good idea is to set this to true from the start. Then, should it be revealed? Now, revealed should be false because we want to first display our hidden image, and then later on, once the collection is sold out, we will then reveal all of our NFTs to the world. Okay, and then we have the not revealed URI, which stays like that. That's all we have to change. So once these changes have been made, you should see this green tick here on the Solidity compiler section. By the way, how Solidity works is it has a file system where all your files, rule of thumb for me is always to put on enable optimization over here. Then we also get the deploy and run transaction section. All right, perfect. But let's go quickly to the Solidity compiler section. Something that you need to make sure of is this pragma line. Just make sure that your Solidity compiler is in between these two specified versions of the compiler, and indeed it is. It also will select it automatically. If your contract doesn't compile yet, if it doesn't do it automatically, you can tick on the automatic compile, and it will do it every time there's a change in your smart contract. Once you are happy with all your parameters that you've set up, go to the deploy and run transaction section. You can find it here on this Ethereum looking icon. The environments that Remix provides us is in browser blockchains. These are the virtual machines. These are great for testing. So if you want to test these smart contracts, you just select one of these and then you go ahead and do exactly the same. And this won't deploy to a real blockchain. Instead, it will deploy to the browser blockchain. But seeing that this is how to deploy on the testnet and then onto the main network, we have to follow the injected Web3 provider one, like this one, okay? So make sure that you are on the injected Web3. Now, this is where you need to pay attention. Currently, it says that you are on the main one network. This is the Ethereum main network. If you try and deploy now your smart contract, it's going to try and deploy on the real main network. So in order to avoid that, go to your MetaMask and go and switch the network over here on your RPC. If you click here and let's select a different network. Now the Rinkeby and the Gurley and all these other networks are test networks. Let's select the Rinkeby network. If we've selected the Rinkeby network, you can see that I've got some test ether in here. You can get test ether from a faucet. There's numerous videos on that. But I can now be sure that I'm on the Rinkeby test network and also see that over here, it says Rinkeby network 4, which is great. When I deploy to the Rinkeby test network, this will actually deploy onto the Ethereum network and we can test it on the test OpenSea, which is perfect for our use case because we want to do that to test that everything is functioning before we deploy on the main network, which is network number 1. On a side note, a lot of people have asked me how can they deploy this smart contract on Polygon? Well, that's very simple. Again, you'll go to MetaMask and select which network you want to deploy it to. I do not have the Polygon test network, but I do have the Polygon main network here. All you have to do to get the Polygon main network on your MetaMask is Google RPC Polygon main network and it will give you the details to set up this RPC. But once you're on that, you'll see that the custom network ID is 137. Keep this in mind because I'll show you this later on in the video when we create the dApp. Anyway, let's get going and let's actually deploy on the Rinkeby test network. So I'm going to go to MetaMask. I'm going to go to Rinkeby test network, virtual JavaScript virtual machine, but then it won't show up on Open this out. What you can do is you can go down on the deploy section. You don't really have to change any of these. You have to make sure that you have some test ether in there. And then you can go and select your smart contract. So make sure that in this contract section, you have selected your smart contract. If you select anything else, you'll be deploying a different smart contract. These are all the dependencies that our one has. Once you have done that, you'll see there's a deploy section where we now have to fill in a bunch of details for us to deploy this. So to make it easy to fill in all these details, you can click on this drop down arrow. You'll see that it gives us a list of things to fill in. I've just placed a lot of T's in there. But the first variable is the name, and you can see that in our constructor function, by the way, a constructor is a function that only runs once, and once the contract is deployed, it will never run again. So on startup, we pass it a name, a symbol, an initial base URI, and the initial not revealed URI. All right. How do we get these details, and how do we actually fill these in? Well, let's think of a cool name for our contract. We want to call this the purple eye, right? So we're going to call this purple eye. Our symbol is going to be PE, and this is just an abbreviation of purple eye. Then we need the initial base URI. Now, we need to go back to Pinata. And I also want to show you that on OpenSea's metadata standards, remember what they said, they want the format like this. So you can go ahead and first type in IPFS colon //. I'm going to simply copy this because at this point, we don't want to make mistakes. Even though this is the test network, we need to act as if it's the real one. So go and paste in IPFS colon //. Okay, then go to Pinata. Once we're in Pinata, this URL is the actual metadata, the real metadata URL. So I'm going to click on I_metadata. This is not the hidden one. Open it up. And then once I'm here, I need to basically copy all of this. But this is now where there's an important thing to remember. You need to have a / when you deploy the smart contract over there. So at the end, add your /. Please remember that. Add the /. I'm going to say it again. Add the / because 99.9% everyone forgets that. So add the / at the end and then copy everything up to the QM. Then yours might look different, obviously. Then go back to Remix. And then after this IPFS colon //, you paste what you've just copied. So your URI would look something like this. I'm going to go back to where we were, and I'm just going to paste it in there. So your IPFS will look, your URL that you put in there will look exactly like this. So make sure that it looks like this. Obviously your CID would be different, but the format should stay the same. Let's go back into Remix. Now we need to provide it the actual hidden URI metadata. So let's go back to Pinata, and let's go find the I_hidden metadata. Click on the I icon, get back to the reason why I'm using the being deployed. I'm going to copy, but it can be rectified. But it's unnecessary to use. Of course, you can update it using the update functions that I've placed in the smart contract, but it's unnecessary to use them after a smart contract has been deployed. But it can be rectified. Anyway, let's go and see if this has loaded up. So there it is. I'm going to copy everything from the QM, but before I do that, I need to put a / and this time say hidden.json, like so. I need to now copy everything from hidden.json because this, from everything from the end, hidden.json included, up until the QM, this is only for the hidden metadata. So you're going to paste it after the IPFS colon //. You're going to paste it there, and it has to have all of that data in there, including the / hidden.json. The top one doesn't have that, it just has the /. I hope that is very clear. All right. Next, what you need to do, and this is super important. I cannot stress how important this is, this next step. Before you forget, go and click on this little button, and this is after you filled in the details exactly as you are going to deploy this contract. Before you click on Transact, you click on this little icon which copies the bytecode. Now you can go back to Visual Studio, maybe create a new folder and call this Info. I'm going to create a folder and call it Info, and then I'm going to create two files. I'm going to create a polygon.txt, and I'm also going to create a new file, and I'm just going to call it ethereum.txt. I don't think txt works on Mac, so I'm just going to call it Ethereum, and I'm going to rename this to just that. So it can just be a text file. But seeing that this is the Ethereum test network, right, because these are test networks, so maybe it's a good idea to append test, because it's not the main one. I'm going to put this there. I'm going to paste everything that I've just copied. Now, once you've saved this, I think when you close the file and open it again, it would have rearranged all the bytecode for you, like so. Just have this saved, because this is needed when you need to verify your contract. Okay, perfect. Let's now go back to the browser where Remix is waiting and ready for us to deploy. Once you've copied that, you can now freely press Transact. Make sure that you are on the Rinkeby test network. You can verify that, like I said, on MetaMask here at the top, as well as that you have some test Ether. This is not real Ethereum. This is you can get this from a faucet. There's a lot of videos on that, like I said. Once you are sure everything is correct, you can hit Transact on this button. It's going to ask you to do a transaction, and this is emulating what will happen if you deploy on the real main network. So just hit Confirm, and just a side note, please review the code before you deploy your own smart contracts. And then you can see after the contract has been mined on the blockchain, you'll see it pop up here at the bottom. You can expand this, and at this point, it's a very good idea to kind of look at all these functions that the smart contract provides. There are a lot of smart contract features and functions, but the main one is this mint feature. I can now go ahead, and as the owner, because I'm on the owner's address over here, I can now go ahead and try and mint. The function will not work if I try and mint one. Why? If I say transact, it says this transaction might fail. And the reason for that is because our smart contract is still paused. You can check the status of your smart contract by clicking on some of these blue buttons. You can see that our base extension is JSON, our cost is that much in way, and then we can also see the max supply, we can see the max mint amount at each given time, the name, the not revealed URI, which is the hidden one. We can also see who's the owner of the smart contract, if it's paused or not, and indeed it is. And then you can see if it's revealed or not. It's still false, and you can also see the symbol. These blue buttons are basically call functions. So they don't cost any Ethereum or gas. They do cost a little bit of gas, but you don't pay it. But it's basically just reading from the smart contract. As we can see, we have a paused contract. So how do we unpause it? Well, there is a actual function that we need to use, and this is now a transaction, a send function, where we need to transact. So in this pause function, you can now open up your contract. So let's say pause is now going to be false. If I type false and I click on pause, it's going to ask us to do a MetaMask confirmation. And once I do, it's going to mint on the blockchain saying that we need to change the status from paused to false. If I now try and transact and I click transact, you can see that it's trying to mint. It's going to tell me the gas that it wants me to use. I'm going to confirm it. And then it will actually mint one on my address that I have specified over here. After the transaction is successful, let's just wait for it over there. We can also keep track of it if we go to MetaMask and see there is the mint and it's being minted. Keep in mind that this is all happening on the test network, but it is really on the test network, and I'll show you now that it shows up on OpenSea. We've got a successful mint. So now I can see if I click on total supply on the call functions that it's 1. I can go ahead and actually try and mint on someone else's address as well. Let me see if I have an account that has more test Ether. This one also has some test Ethereum. So I can go ahead and connect it, and this will change. And then I can also go and try and mint one over here. So instead of trying to mint 1, I'm going to try and mint 3, just to show you that because we've set our maximum mint amount to 2, if I try and transact, it's going to tell me it's going to fail. This won't happen in the real world. It will fail. But Remix is nice enough to let us know. So let me try and mint 2 at a time. I can transact, and it says the gas estimation error occurred because it can't really estimate how much gas it's going to need to actually complete a successful mint. And that's these days a problem, that you need to kind of specify the amount of gas that you need to put through, but also have the correct parameters. So what are the reasons why this would fail? Well, if you see here, it requires, if a person is not the owner, that they need to pay for it. And we know that we need to give it some way with Ethereum, right, into the smart contract to mint 1 NFT. And 1 NFT costs us 0.02 Ethereum. So how much way is that? Well, we can go down and see the cost in way over there. So I'm going to copy this cost. I'm going to go up and put it here in the value parameter. Once I've done that, this is for 1 NFT. So I will be able to mint 1, but not 2. So I need to kind of up the value to maybe 4, just so that I can mint 2. So once I've done this, I can say transact, and there you see it's now going and making a transaction, sending 0.04. If I confirm this, it would start minting my NFT. Now that we have successfully minted another 2, we can go and double check it on the total supply. It should now be 3. So if you click on total supply, it should be 3. You can also take the address that you've now used to mint these and place it in functions such as the wallet of the owner. And if we do that, so let's go and get this address that we minted with. If we do that, we can see that this owner now owns the ID number 2 and 3. We can also add whichever token ID we want to, and we can get returned our token URI. This is the URI that OpenSea uses to go and grab the metadata, and here you can see it's still hidden because our contract is not revealed yet. I'm sorry for the thunder in the back, but it's beautiful. I love the nature, so we're just going to keep on going with the tutorial. I hope you guys can still clearly hear me. Anyway, we also got some interesting functions on our smart contract, such as the token of owner by index. This is an array of the token owner's personal index. So if we set index 0 of what the owner of this contract owns is number 2, and indeed it is. That's the ID because it starts at 0. If we were to put the owner's address and put 0, it would be 1 because that's their array, right? This is an array of the token owner's personal index. So if we set index 0 of what the owner of this contract owns is number 2, and indeed it is. That's the ID because it starts at 0. If we were to put the owner's address and put 0, it would be 1 because that's their array, right? Then we have token by index address and put 0, it would be 1 because that's the ID. Index 0 of what the owner of this contract owns is number personal index. So if we set index 0 of what the owner of this contract owns is number 2, and indeed it is. That's the ID because it starts at 0. If we were to put the owner's address and put 0, it would be 1 because that's their array, right? It's owner by index. This is an array of the token owner's personal index. So if we set index 0 of what the owner of this contract owns is number 2, and indeed it is. That's the ID because it starts at 0. If we were to put the owner's address, so if we query token index by 0, this should be 1. If we do 1, it should be 2. This is just how it works. It runs 1 ahead because we start minting from 1. Then we also have this function which is to do with the standards of the contract and the owner of the token ID. So if I say who's the owner of token ID 3, then I can see that it's this address that we've minted it from. And there are numerous of cool features that you can. Then some of the more complex features of this contract, but very cool, is you can actually set a new cost, a new base URI, a new base extension. You can safe transfer your NFT to someone else. Then you can also reveal the smart contract by just clicking on it. And a very dangerous button is the renounce ownership. Do not click on that if you do not really want to give the ownership away. Then you have this pause that we've tried, and obviously the mint and approve. Approval basically just approves someone else or another contract in order for them to interact with that NFT. And that's usually why you see a lot of approvals when you interact with OpenSea. Lastly, we get the withdraw button. Now, as you know, we have sent some ether to this contract when we minted with this last person. Let's go and try and call withdraw, but let's stay on this person's address and see what happens. It's going to fail. And the reason for that is because we are not on the original owner's account. Let me switch back to the original owner and then call this. Before I call this, I want to verify how much ether I have in my account. And this is 9.51. If I click withdraw, it's going to kick off a transaction. And once it's successful, we should see the total 9.51 change, and indeed it did. And I withdrew all the funds from this contract that people have paid to mint, right? And you can call this over and over and over again. Something very important to pay over to ETH's account. Now, as you know, we have sent some ether to this contract when we minted with this last person. Let's go and try and call withdraw, but let's stay on this person's address and see what happens. It's going to fail. And the reason for that is because we are not on the original owner's account. Let me switch back to the original owner and then call this. Before I call this, I want to verify how much ether I have in my account. And once it's successful, we should see the total 9.51 change, and indeed it did. And I withdrew all the funds from this contract that people have paid to mint, right? And you can call this over and over and over again. Something very important to do at this stage is to, at the top here, copy your contract address by clicking on that copy button. Head over back to our Visual Studio, and because we have this file that we've created, let's add a few spaces and put our contract address in there for our test contract. This is the contract address that we can find on the test network scanner, right? This is just information you want to keep, and I'll show you a control panel to work with your smart contract that's interacting with the smart contract that's existing on this blockchain. We can still see that this is live and it's interacting with the smart contract although this is the Rinkeby test network, we can still see that this is live and it's interacting with the smart contract that's existing on this blockchain. Now, in order to see our work, we can head over to OpenSea. Well, not the real OpenSea. The real OpenSea will only show your artworks and your collection if you have deployed to the network with ID 1, with a real main network. And therefore, because we have deployed on the Rinkeby test network, not the top one here, the main network, which will cost us real Ethereum, we can still test it on OpenSea, but we have to go to the test net. So we have to type in test network. So you also will see OpenSea URL looks like this. See, big reveal, there's actually the Purple Eye collection is live. Now, because you own this collection, you can actually go to this collection yourself, and on the Purple Eye collection, you can click on it, and you'll see there should be 3 items, because remember, I minted 1, and then on another address, I minted another 2, so there they are, and they're not revealed yet. And you can go and edit your collection. If you want to put a new image over there and a background image, you can click on the edit button at the top. Is that you can set the percentage of your royalty fee here, so you can maybe set it to 2.5, and then you set a wallet address that you want this to be paid to. Now, that's all, and you can hit submit and update. But because this is on the test network, I feel there's no need of doing this. Simply, we want to test our smart contracts, and then once we're happy, you deploy to the proper network. If you are happy with your smart contract and it's working fine, you will then go the step further and go and deploy it on the real main network. But we haven't stopped testing our smart contract. Let's say our sale has ended, and we want to reveal the smart contract. We want to reveal these images. Well, let's click on the collection and just have it open like this. Let's go back to the Remix control panel, and if you haven't closed this yet, you can still work with it on your browser. You can keep this open for as long as you want. I will show you a way, however, to get this back if you accidentally close down Remix. Alright, so next we can also see that if we click on this reveal button, making sure that we are on the owner's account, we can say confirm, and once we have done this, it will take a transaction, and once the transaction is complete, then our collection will be revealed on OpenSea. Let's wait for this transaction to finish. We can see that it might take a few seconds. There it is, it completed, reveal, and if we go back to OpenSea now and we refresh.
Yeah, so एक नवीन गोष्ट लक्षात आली ती म्हणजे you can create add royalty on OpenSea even when NFT is minted through our code. जे त्यांनी आता स्क्रीनमध्ये दाखवलं होतं की ओपन सीवर आपण ॲड करू शकतो. सो देन द क्वेश्चन इज की जर रॉयल्टी आपण तिथे सेट केली आहे कोडमध्ये, जसं याने सांगितलेलं इफ द ब्लॉक्स याने, तर मग काय ओपन सीमध्ये ते ऑटो पॉप्युलेट होईल आणि सेट होऊन जाईल की तिथूनही चेंज करता येतं. दीज आर द क्वेश्चन्स देन.
Refresh this page, we can see that if we go down below, it's not refreshed the metadata yet. And if that happens, all you need to do is go onto your collection and click on refresh metadata up here. This tells OpenSea that there's new metadata that it needs to pull in, and it will go and do so. And then once you get back to this image, it will actually show up. If you have bigger collections, it's better to go and call OpenSea. Otherwise, you can just tell the community to hit refresh metadata. That's why this button is there. Action. And inside of this function, or on this function token URI, if we call it again, I'm not going to change the parameters. This hidden should change to the proper URI, and indeed it does. So we can expect this to work. We can also pinata test case that we've used, so we can see if we call this, there's our metadata. So OpenSea will update this as soon as you have clicked refresh. Our pinata test case that we've used, so we can see if we call this, there's our metadata. Just verify connected or on the main network. You basically have to change nothing. Or you can simply go to the Ethereum main network like so, make sure you have some Ethereum in there, and then once you have these already filled in, if you change something in the contract, it's going to go away. You need to redo this and you need to recopy everything like I showed you. But if we hit transact, it's going to say that this is going to be the cost, and if I say confirm, it's going to say this is going to cost me $414. Do this and actually follow the verification steps as well. Now let's just double check on OpenSea. Maybe they let's go Rinkeby. Perfect. Now you can see that the metadata actually has updated. And how can I see that? Well, it now says #1, which is the actual name of this NFT. We can also see that it says the coolest NFTs, meaning that it is pulling in the right metadata. It's just not refreshing the image. So that might take some time, but give it some time for the metadata to pull it in. If you are really stressed about it, you can always verify it. Like if you want to say owner of a link, just try it out. Yes, colon. Once you've done that, the image shows there. So just give Ike and metadata. I deploy on. It's now pulled in the images as well. And now you can see that they are revealed. And how cool is that? Mix, okay? And we can actually now get rid of the smart contract. But this is not the flow that I usually follow. I never get rid of a smart contract before I verify it. But seeing that this is on the test network, I really do not care about this smart contract. I usually do the following steps only for the mainnet contract. Okay, so this is the real deal. This is where we either deploy to Polygon or Ethereum, and each one will work. And the reason why I say that is because I just proved that I deployed on the Rinkeby test network for Ethereum. I'm not going to deploy to the real Ethereum network. That is very expensive to just make a tutorial on, and I don't want to put messy content on that network, right? But Polygon is affordable enough, and I can really dive into doing it on the real network and test it out and actually show you guys how to do it properly on Polygon and Ethereum. But all you have to do, and the only change you need to do, both for Ethereum mainnet and Polygon mainnet, is simply go to your MetaMask. Go and make sure that you're on the network that you want to deploy to. So if it's Ethereum, you'll select Ethereum. You'll go and make sure all these details are correct, the correct contract. All these things are in there as it should be. You copy the encoded bytecode and you transact. And then you go and confirm and you pay the gas fees and everything that you want to deploy for. This is quite high. But anyway, that's how you deploy on the Polygon mainnet, on the Ethereum mainnet, sorry. When we get to the Polygon mainnet, I have already set up my RPC on MetaMask, which means it's just pointing to the main network. So I'm going to switch to the Polygon main network. And once I am sure everything is fine, you see, it's exactly the same process. You copy the bytecode. Like I said, this is for real. So we're going to copy the bytecode first. We're going to go and do our best practice of pasting this somewhere. So we keep track of it. Remember, we did the same with our test network, but this is now the Polygon one. So if we go back, we can go ahead and make sure we are happy with everything. I do have to mention that 0.02 Polygon or Matic is quite cheap, but I'm going to just keep it like that. Usually when you work with Polygon, you can make this in the 1, 2, 3, 4, 5, 6. It's not Ether, but I'm going to leave it like that because as soon as you change the smart contract now, you'll have to retype in all these details. But go ahead and make sure you configure it to your needs. So now that I click on transact, I will get the pop-up and I'm going to be saying confirm. Now what happens is exactly the same process that happened when we were deploying to the test network on Ethereum. But now this is actually doing the transaction on the real main network of Polygon. And you'll see it pop up on the real mainnet, and we can go to the real OpenSea, and I'm going to really reveal it. So let's wait for this to finish. In the meantime, when this transaction is finished and it comes in here, or if it gets finished and you find it on the scanner, you need to copy that address and also follow the best practices where we can actually then copy the address and put it in our file that we are saving all of our details to. I'm going to go ahead and speed this transaction up. Okay, it wasn't necessary. It's done. Means that it shows up here at the bottom. There's the address. I'm going to copy it immediately, the address, and going to Visual Studio and just going to make a few spaces and paste it. This is now our main network's address, and you can actually scan this and it will be live there. So the next thing that I need to do is I can go back over to my remix. So the next thing that I need to do is just open it and make sure everything is fine. Maybe I want to mint one. So what I'm going to do is I'm going to unpause my contract. So I'm going to say this should not be paused because I want to actually I want to interact with my smart contract. So let's kick that off so long so that the contract starts running and it's done. And I want to mint a few. So I'm going to actually mint 5 for myself. And it says gas is not going to work. Why is that? Let's see why. Is it still paused? So let me go and see if it's paused. It's not paused, so I don't know why it would do that. So let me just quickly check. Oh, because we cannot mint more than 2 at a time. Fine. So let's mint 2. So I'm going to mint 2, it's going to pop up MetaMask, and I'm minting 2. And this is how you can do it from your little control panel, so to speak, okay? Now, the other stuff that we need to now go and copy, which is very important for the smart contract, and I'll show you in a second, is the ABI of this contract, because this is what we'll use when we create the dApp. Okay, it looks like our transaction is successful. If we look at the MetaMask over there, it's gone through. So that is pretty cool. So the next stuff that you need to copy is the ABI. So what you can do is go to the Solidity compiler, make sure that you have the exact same smart contract that you use to deploy your contract in here. And then down here where it says contract, go and select your contract. Once you've done that, you can go ahead and copy the ABI. Okay. Then go back to Visual Studio, and I'm going to make a bunch of spaces and paste the ABI. So I'm just pasting in all the information that I need, right? I'm keeping track of everything, and I'm going to show you how useful this is later on. I'm going to make another, basically another file. So in the info, I'm going to say create new file, and I'm going to say Polygon contract. And this is going to be the Polygon contract that I used, basically everything in here. So I'm going to press Command A to select the whole contract, copy it, go back and paste it in here. The reason why I do that is for if we lose the ability to actually salvage our remix. When I do that, you'll see that there's a way that I can re-upload this contract onto our remix platform, meaning that I'll have access to this beautiful control panel again. Otherwise, I will have to make use of the Polygon scans methods to kind of execute everything on there. But I can only use Polygon scan, for instance, Polygon scan over here, and Etherscan, if you have deployed this to the Etherscan or to the Ethereum network, if the smart contract is verified. How do we verify a smart contract? Well, at this point, this is why we have copied all this information. Let's go ahead and actually verify the real smart contract that we have just made for the Polygon network. All right, here we have all the details. We have all the ABI constructor functions. We've got our ABI contract functions over here, the JSON format, and then also we have our contract address. So go ahead and copy the contract address that you have saved, go back to your browser and go and search for it. You're going to basically search for this now either on Etherscan, on Polygon, or Polygon Scan based on which blockchain you have deployed to. Now I can see that here's my smart contract, and here is the Purple Eye PE smart contract, and there's already 2 minted, right, and 1 address owning it because we just minted 2. So I can see that there's 2 mints. How cool is that? Your smart contract is live, and it's pretty cool. So technically, if I now go to OpenSea, let me go to OpenSea and check it out. So if I go to my profile, I should see that there's 2 new items in here, which are these eyes. So how cool is that? It is pretty cool. Now I noticed that they are on the Polygon network over there, but I'm not seeing the actual images. But I do see that it says Purple IV2, Purple IV2, and that is because like someone actually have created this before. So if we search for Purple Eye, there's actually a collection that exists that's called Purple Eye. I didn't know that. But now I've also got a collection, but it's V2. So that was an accident. But yeah, if there's a contract with the exact same name, it will show up like that. Now, I don't see the image yet, and I think it's just because OpenSea is a bit slow with this. So if I maybe refresh the metadata, I do know it is putting in metadata. And the reason why I know this is because it says Purple Eye there, and in the description, remember, we typed in this image is hidden. So it is putting it in. I think it just takes a bit of time for it to, fully populate because it's a new NFT or something like that. But we can go ahead and test it. Like I said, if you want to always go and test and make sure everything is fine, just go and query that token URL. and replace it in there, and then replace that. You can see this is the JSON, and again, we can just go and replace it in there. Once we have it, we can see our image is located at this endpoint place. Maybe we can query number 1. We can see that this is the JSON, and again, we can just go and replace it in there. Once we have it, we can see our image is located at this endpoint, so we can then replace that. And if we hit enter, there's our image. So OpenSea just takes a little bit of a while. It also did this just our purple. If we come back here, that this will already be showing. So we basically have our contract now set up in place. Now, the important part here is to verify the contract for us to, on a later stage, either interact with it.
Yeah, so note that total supply is 2 PE कारण 2 NFT mint केलेत
deploy to both networks.
Polygonवर.
You can see that we have a read and a write, but there is no ABI at yes, so we can verify that by going to the details that we've copied, and indeed it is. So the next thing is we need to select a compiler. To find that out, we can go back to Remix, go to our compiler section, and see that we used 0.8.7. So when we go back to Polygon Scan, we can select, well, first we need to select a single file because we didn't use multiple files, we used a single file. And then we select our compiler, which was 0.8.7. And then lastly here it says if there was a license. To find out the license, again, you can go to Remix and scroll all the way to the top of the contract and go and find our license, which is a MIT license. So we can just say this is MIT. And then we hit continue. After that, Polygon Scan is now going to ask us a few more questions. And the first question is going to ask us, was this optimized? And yes, we did turn on optimization. Remember when I said turn on enable optimization over here, that's the only thing it refers to basically. Then what we can do is we need to paste our entire file in here. Now I already told you to go and copy your contract. You can either copy it again from Remix or copy it from your contract that you've saved it now as your info files. Let's go back, let's paste the contract in here. Lastly, it's going to ask you for this ABI, encoded ABI, constructor arguments. This is only needed if you passed in constructor arguments when you deploy a contract. And indeed, we did because we filled in all this information. That's why it was very crucial to copy this. If you haven't done that, it's very difficult to go and verify it afterwards. Remove everything in this file, then go to Visual Studio Code, go to this Polygon file that we have selected, well, we have copied and pasted, and then go and check this last bit of the bytecode. In this video, I'm going to show you how you can create your own collection on OpenSea and Remix. Okay, only for say that if we see that it's verified, meaning that we can actually query past it. That's why it was very crucial in copied and pasted. And so you'll see, and it has the last zero pasted in there, and say that you're not a bot first try. A lot of when they deployed the smart contract. So this should take a few seconds. Everything worked out. There's our smart contract. There's all the bytecode contract. And by the way, we should be able to search for it in the search bar. So if we type in purple eye, there we go. That is our smart contract. So you can even search for it like that. But that being said, if we now click on the contract over there, you'll see that it's verified, meaning that we can actually query everything in here. And this is very good because now technically we do not even need Remix. But that being said, there's a bunch of stuff we can query, but we can also write. So when you read contract and write contract, reading and writing are two different concepts. Where I told you about reading a contract is the free kind of functions of the contract calls, where writing actually takes some gas that you need to provide. It's the same concept as looking at these orange buttons as writing plus the red one and the blue ones as the reading. Okay, so you can also withdraw from your smart contract when you are doing this from Remix or from Polygon Scan or Etherscan. What you do is you can go to the write contract and you need to just verify and log in with your MetaMask wallet. So let it just load. You can see it asks you to connect over there contract. You can reveal, you can pause the smart contract. Very confusing for a lot of people. This withdraw method all of a sudden has this field, right? And it's strange because on Remix, it doesn't. It is just a withdraw. Well, on Polygon Scan, that field is basically the value field. And that's why it's there. So please, if you withdraw, do not put a value in there. You will only be sending money to your smart contract. So if you want to call the withdraw, put a 0 because you don't need to send money. You're just withdrawing because you are the owner and you can simply call it. All right. And that's all how it works. Basically from Polygon Scan or Etherscan, the verification steps are the same. The way you call smart contracts are the same. Everything is the same. And there you have it. Now you are done and you have a successful contract on the blockchain, which is verified too. Let me quickly show you some nuances and tips and tricks with Remix. Let's say you got back. back to Remix, and for some reason your contract was gone. You closed the browser, you don't know what to do. Don't panic. All you need to do is head to the file where your smart contract was saved, go and copy that, go back to your browser, paste it in there, wait for it to get a green tick over here on the left hand side, then go to the deploy and run transaction section. Make sure that you are on the environment injected Web3 and that your MetaMask is pointing on the same network that that contract was deployed to. Next, go back to Visual Studio or wherever you have saved your contract address if you've lost it, and you can copy that, go back to your browser, and then you need to paste it in here, address, right? Do not go and deploy this. You need to also make sure that you're on the right contract. So make sure that you're on Purple Eye contract. Even though this looks tempting to go and enter these details again, do not do that, because all you'll be doing is deploying another instance of your contract on the blockchain, and that you don't want. You want to interact with the same instance if you want to do it through Remix. Otherwise, you can just carry on interacting with your smart contract on Polygon Scan or Etherscan if it was Ethereum. Okay, but that being said, if I click add, it should for OpenSea to realize I'll now reveal the metadata from Polygon Scan or Etherscan. Like I said, you click on contract, you should do it from here, so that you do just the same as if you were to do it in Remix. And that's once you do it from here, it is just have to finish, and then we're going to just refresh the metadata. I'm going to maybe, so that you don't always have to depend on Remix, because everything can be done from Polygon or Etherscan. Let's wait for that transaction to finish, and then we're going to just refresh the metadata. I'm going to maybe speed this transaction up a little bit so it happens a bit quicker. As we can see, the reveal is successful. So now let's go back to OpenSea, and then once users are on action, let's hit refresh on the other one. And if you want to do this in bulk, that being said, as once populated, see, it should start saying maybe this is #1, and I'm not going to wait for too long because I want to actually show you the next part and the final part, and that is actually hooking this contract up. That is now, and final step, app, this one. So React. So click on terminal here, the creator. We have to show you how you can host it, run this application. Bottom of your app before you actually need 3000, which means see that the server is busy starting up.
Okay, so let's quickly write what we learned from this particular video. What we learned from Hashlips video. Minting on Polygon simply means set the network on Polygon, set the amount in Matic or Ether along with necessary value to reveal pods or extra fields to manage contract to owner, verifying the contract on Etherscan by pasting code and API. What else? Hidden, hidden, reveal, and these three things. What else? Confusion. Video shows Matic is accepted while OpenSea docs don't say anything like that. As in, OpenSea accepts ETH on Polygon or USDC DAI on Polygon, but not Matic. So is it really a good idea to set the amount in Matic? Does it even work? I mean, we didn't see pricing in his video. जेव्हा त्याने अपलोड केला तेव्हा प्राइसिंग पॉप्युलेट नाही झाली आणि 0.02 अमाऊंट होती, तर तिथे 0.0004 दाखवत होता पॉलिगॉनला, which is a bit confusing. Let's see. Okay, why so many spam? Okay, so probably somebody has created a bot which continuously checks की लाईव्ह स्ट्रीम चालू आहे का, आणि लाईव्ह स्ट्रीम चालू असेल तर तो ऑटोमॅटिकली मेसेज फॉरवर्ड करतोय लाईव्हमध्ये. सो लोकांचं अटेन्शन वेधण्यासाठी a bot is looking for live videos and commenting on the live videos, which is a good strategy actually. I mean, I will give him that. And it's bad that एवढे सारे रिपोर्ट करून सुद्धा, आय मीन आफ्टर बिफोर अ व्हाईल 3 वेळा मी स्पॅम मार्क केले, तेव्हा सुद्धा गुगलने काही ॲक्शन घेतली नाही. इन द सेन्स मशीन लर्निंग अल्गोरिदमने अजून इतक्या लवकर पिक नाही केलं आहे किंवा मग हे नवीन अकाउंट दिसतोय. बट स्टील दिस इज व्हेरी इझी टू डिटेक्ट वेदर इट्स अ स्पॅम ऑर नॉट. एकाच अकाउंटवरून मल्टिपल येत असतील तर तुम्ही करू शकतात, थिंग्स लाईक दॅट. So we can probably ask him here कि matic accept नाही होत तर what's the scene. But because upload तर झाला होता याचा कोड, आणि त्याने 0.02 इथरच्या ऐवजी 0.04 इथरच ठेवला होता आय थिंक त्याने मॅटिक शब्दाच्या ऐवजी. सो फॉर एक्झाम्पल आपल्याला इथे ते कळेल कुठे.
On the blockchain, give the ownership away. It's better to go and call OpenSea. Otherwise, you can just tell the community to hit refresh. Maybe it's going to be the cost, and if I say confirm, let's going to be the cost, and if I say confirm, it's going to say this is going to cost me $414 on the real, quite high. OpenSea, and I'm going to really reveal it. So let's wait for this to finish. In the meantime, when this transaction is finished and it comes in, but now this is actually doing the transaction on the real main network. We type in all these details. But guys, we can go ahead and make sure same process. You copy the bytecode, the encoded bytecode. Ethereum to do it properly on Polygon and Ethereum, doing it on the real network, right? But Polygon is affordable enough, and I can really dive into doing it on the real network and test it out and actually show you guys how to do it properly on Polygon and Ethereum. But all you have to do, and the only change you need to do, both for Ethereum mainnet and Polygon mainnet, is simply go to your MetaMask. Go and make sure that you're on the network that you want to deploy to. So if it's Ethereum, you'll select Ethereum. You'll go and make sure all these details are correct, the correct contract. All these things are in there as it should be. You copy the encoded bytecode and you transact. And then you go and confirm, and you pay the gas fees and everything that you want to deploy for. This is quite high. But anyway, that's how you deploy on the Polygon mainnet, on the Ethereum mainnet, sorry. When we get to the Polygon mainnet, I have already set up my RPC on MetaMask, which means it's just pointing to the main network. So I'm going to switch to the Polygon main network, and once I am sure everything is fine, you see it's exactly the same process. You copy the bytecode. Like I said, this is for real, so we're going to copy the bytecode first. We're going to go in with our test network, everything. I do have to mention that 0.02 Polygon or Matic is quite cheap, but I'm going to just keep it like that. Usually when you work with Polygon, you can make this in the 1, 2, 3, 4, 5, 6.
So
It's not
at
Ether, but I'm going to
this
leave
145, this is the question. At 1.45.00 video. This is the question.
it like that, because as soon as you change the smart contract now, you'll have to re-type in all these details. But go ahead and make sure you configure it to your needs. So now that I click on transact, I will get the local, so it can just be viewed on now running. We're going to do a build, and I'm going to, what is happening over here? So firstly, this is a dApp that you
Okay, so जेव्हा okay. Abang is a silly point because we are minting with our contract, so we don't have to think about OpenSea. We can mint in our currency and token in our token and network, which happens to be Matic and Polygon respectively. So minting will be done and people will pay in Matic on Polygon. The question now is, how will OpenSea treat this? कारण हे इम्पोर्ट होतील OpenSea जसे तसे आणि OpenSea probably त्याला रन टाइमला कन्वर्ट करेल. I don't know. I mean, that is worth looking actually. So जेव्हा
An
याने
ID3
launch केला
that you can new cost and you base
145
your
ला
IC. It's going to be find it on the scanner.
इकडे
Unique file works is
इथून डिप्लॉय केल्यावर आपल्याला बघायचं OpenSea काय केलं.
when meaning that and
0.02.
if the smart contract is verified, how do we smart contract? I should see that there's two new items in here, which are
दोन
these
ऑब्जेक्ट्स आले
ties.
आहेत पण
So
त्यांची
how cool is
कॉस्ट नाही
that?
माहिती.
It is pretty cool. Now I noticed that they are on the Polygon network over there, but I'm not seeing the actual images. But I do see that it says purple IV2, purple
ओके,
IV2.
त्यांची प्राइसिंग केव्हा येईल? बिकॉज अमाऊंट आपल्या अकाउंटमध्ये आली आहे, कॉन्ट्रॅक्ट चार्जेसमध्ये अकाउंट अमाऊंट आली आहे आणि OpenSeaवर ते लिस्ट झालं आहे आणि OpenSeaमध्ये लिस्ट झाल्यावर ओनरच्या मेटामास्कवरून व्हॅलिडेट होतं की हे कोण ओन करतं. ओके, सो त्या पॉईंटला मला वाटतं ओनर स्वतः डिसाईड करेल की ओनर स्वतः डिसाईड करेल की मला हे किती इथला किंवा किती USDC ला ठेवायचं आहे. राईट. सो answer, the owner will see his NFTs on OpenSea and he wants to put it up for further sale, he will simply put up some cost in OpenSea's terms, that is either USDC or ETH on Polygon or ETH on Ethereum. Yeah, sorted. Yeah, simple confusion but sorted now.
Our purple eye collection is live too.
ठीक है, पुढचा
So,
पार्ट वेबसाइट
We
मिंटिंग
can
चा.
just reject
वेबसाइट
this. I only
मिंटिंग
want to
इज
mint
इजी.
one. So well,
Let's not
actually,
get into that. So I think this was good. This was really good. So I give him a thumbs up. And this
Ladies and gents, this is the
NFT minting dApp हा होता. यामध्ये त्याने तेच सांगितलं असणार. सो लेट्स इग्नोर दॅट. सो आपल्याला आता काय बघायचं आहे, आपल्याला हे कळलं की आपला स्वतःचा कॉन्ट्रॅक्ट आणला एवढ्याच गोष्टी चेंज करायच्यात. हार्ड हॅट कसं वापरायचं आहे ते आपल्याला बघायचं आहे. सो वन वे इज टू डू विथ let's say couple of ways of deployment, right? So deployment ways, let's just write this. So deployment options. So first is remix with control. Remix मध्ये दोन ऑप्शन्स आहेत, कंट्रोल पॅनल इन रिमिक्स itself किंवा व्हेरीफाय the contract आणि interact from ether scan or polygon scan. And the other option is which is good one is probably something like hard hat or truffle or brownie. So आपण यांचा पण थोडासा हे बघू. we'll see. Brownie spelling is wrong, I think. Brownie, I don't know, or maybe is it I. ओके. सो हार्ड हॅट किंवा हे याच्याने आपण बाकीच्या स्क्रिप्ट्स बाकी गोष्टी पण कंट्रोल करू शकतो. सो आय थिंक सो आपल्याला काय बघायचं बाकी आता की हे फंक्शन्स व्यवस्थित बघायचे, स्मार्ट कोड व्यवस्थित रीड करायचा आहे. सो दॅट इज टू डूमध्ये जस्ट राईट टू डू टू डू. सो रीड एंटायर ERC 721 contract carefully, each function. Then hard hat features versus brownie or truffle. Pros and cons with remix versus hard hat. त्यानंतर uploading IPFS automatically rather than manually. That is one. And I don't think there is any substitute. I mean, आपल्याला जर म्युझिक किंवा व्हिडिओ किंवा इमेज अपलोड करायची आहे, I think we have to, there is no way to go around it. So I think maybe how to use IPFS/Pintala, that could be one. सो ठीक आहे, लेट्स से आपण IPFS मध्ये मॅन्युअली अपलोड केला डेटा. 50 NFT आहेत, 50 NFTचा मॅन्युअली केला किंवा जसं कोडमध्ये जेसन तयार झाली आणि मग जेसन अपलोड केली पिंटाला वापरून. सो वाय पिंटाला वापरलं तर एकदा चेक करू आपण. वाय पिंटाला वॉज युज्ड. पिंटाला NFT और पिंटाला पिनाटा. या पिनाटामध्ये काय बेस्ट इन क्लास NFT मीडिया युअर NFT शेअर युअर NFT. ठीक आहे. पिनाटा इज ओपन powerful established NFT storage. From day one, Pinata makes file storage when it's images, video, easy. Okay, Pinata is actually useful. So Pinata versus IPFS is the question. Pinata versus IPFS. What is the difference? कोणी काही लिहिलं नाही. Okay, Pinata versus comparing IPFS services. Pinata IPFS or OpenSea. Yeah, let's check this one as well. Check. Okay, comparing as we outlined potential device storage. We feel that benefits. Pinata IPS or OpenSea. NFT is not an image, or it is just cryptographic digital sign that proves that. So you buy NFT, you just buy the sign, not exactly the image. From the other side, when you upload an image for your NFT to OpenSea or the it stores on the private, so only they really control if the image you upload is still there. From the image to IPS, no matter through Pinata or other pinning services or your private IPS instance, it will be accessible with the same link until the last pin to in the network will be removed. So there can pin the image himself and nobody can remove it. Right. So okay. So it seems like Pinata आपण IPS वर launch करू शकतो. So I missed that Pinata part actually. We'll see in some video. Do you know if they have open source? So when you go create a new asset, I have the option to upload it there as well. So automatically sends this file. If that is the case, why would I use a service like IPS? The question is right की OpenSea वर केल्यावर कशाला वापरायचं आहे? Yeah, so NFTs are using IPS because it to maintain the article. याने क्लिअरली मेन्शन एक्सप्लेन नाही केलंय की OpenSea वर करताना IPS ची गरज आहे की नाही. So let's see. I recommend Pinata IPS. If you do not want to host your own IPS node, I'm not sure when they start charging. Okay, so Pinata might be like IPFS might be paid, charged. Upload image to IPFS. Generate compliant JSON. Upload metadata files. Okay. इमेज आधी IPFS लॉन्च करायची आहे. देन JSON NFT जनरेट करणार एक JSON मेटाडेटा JSON फाईल तयार होईल. JSON फाईल परत IPFS वर टाकायची आहे. ओके. So we need to understand how, let's say, the token, owner of token, metadata associated token. Here an example, okay. So you can see that ID is nothing but a unique positive integer. Owner columns, address, stores, data associated with binary metadata. The column they may contain data. It is possible to store the entire image in metadata column. Storing data on blockchains to give a contact collection occupies 600 MB worth of they will not get data about NFT, right? This data is stored in the form of JSON, right? So basically userला JSON मिळतं. If you don't know JSON, for purposes, think of it as a Python exchange. So this JSON needs to have information about NFT, right? Description, image, URL, attributes. So basically JSON मध्ये सगळे डिटेल्स आहेत आणि त्या युजरला JSON मिळतंय जेव्हा NFT विकत घेतोय तेव्हा. In short, what's in no JSON, here is a JSON. So JSON मिळते म्हणजे यामध्ये ह्या गोष्टी मिळतात आणि मग ही इमेज मात्र ओपन इथे होस्ट केली आहे IPFS वर, त्याच्यामुळे मग त्या IPFS ची ती इमेज डिलीट होणार नाही. सो ती इमेज नेहमीच तिथे राहील आणि ही JSON एडिट चेंज नाही होणार, त्याच्यामुळे JSON बरोबर राहील, त्याच्यामुळे इमेजही लोड होईल आणि JSON लोड होईल. Is the whole concept. You're storing data is JSON. To summarize, upload all images and get URL. Generate separate JSON file for each image. Upload JSON files to cloud, right? आणि मग ती JSON ची फाईल मिळेल. Uploading images is very easy. ठीक आहे, it wouldn't be a very centralized tends to be ठीक आहे, जाऊ दे. iOS use for containers, go to Pinata. Uploading IPFS is to thanks to service called Pinata. Okay, IPFS for upload करायला Pinata वापरतो. That is good. So let's just link this article as well, and somewhere about uploading image JSON, IPFS and Pinata. This is a good article. So use Pinata to upload image on IPFS. Use the image hash and put it in the JSON. Upload JSON to IPFS and get a hash. That hash represents JSON, which is what the user will really get when he buys the NFT. This was a good article. Yeah, so image upload करा, पिन ठीक आहे, आणि मग त्याच्यानंतर अशी इमेज मिळेल. ठीक आहे, IPFS URL you will not open to do that, you need to use ठीक आहे. Then this image will upload to folder compilation compliant JSON. So since we uploaded image to IPFS, now we have IPFS URLs for each every image. Create JSON file for each image. Generative art NFT library heavy duty, right? ठीक आहे. So ही अशी तयार होईल काहीतरी. यांनी पायथन वापरून JSON तयार केली आहे. Upload JSON metadata files to third step is very simple. Just okay, yeah, JSON. This is good. Alright, so that thing is sorted. Pinata is sorted. Okay, so upload cost of video and audio on IPFS. That is one thing to look for. So let's say to do ठीक आहे, आधी चेक करून बघू काय IPFS hosting video lifetime 1300 or 400 first of all. Files. IPFS are free to use as such, there is no cost. But if you store data on your IPFS, they will be around until you unpin them and run garbage collection. You can use pinning service to store your data on IPFS. and not have to deal with managing your own nodes. For this, however, the cost will vary depending. 0.14 per GB, ठीक है, it's not much. मैं रनचा सर्व्हिस कॉल टेम्परेचर चार्जेस 0.05 per GB. That is fine. So आपल्या पिनाटाच्या वेबसाईटवरून कळून जाईल ॲक्च्युली. पिनाटा पिनाटा. सो जर आपण पिनाटा नाही वापरलाय तर आपल्याला आपला स्वतःचा नोड होस्ट करावा लागेल आय थिंक. सो अपलोड इमेज ऑन IPFS. Let's see very quickly. Not through Moralis, but yeah, Moralis is also good. Moralis we gotta check sometime. Let's see what Moralis has to offer. Not Moralis. Uploading IPFS normal upload to create. They will receive data from browser and then store it somewhere. It will visualize like. We could write server code, accept data and push it onto. But what if browser could upload directly to IPFS? Then the previous 2 MB upload becomes 1 MB again. This is nice because we save on network cost. There is nothing wrong. Okay, client, browser, server, and storage. It allows the developer to write server code to modify them. For example, there could be multiple storage solutions. All the solutions increase the amount of bandwidth. It becomes 2 MB because the server needs to upload it onto storage solution. Okay, yeah. And client browser could direct IPFS वर. We could write push it up, but what if the browser could upload directly? Yeah, so browser on direct storage में नहीं जाते. That's why it's saying. So to run you need IPFS node running on your computer. To make tutorial you also configure the course IPFS install that will start IPFS server locally. We are configuring IPFS return. There are several ways to you can use server. Okay, using Python, using file system. IPFS image uploader. Having the browser directly open, bandwidth reduced to developers normally. To upload image, a client will upload to server which intends to somewhere else. Upload creates instant const file reader. Give reader as a file buffer. Add equal to photo bind reader to unload initial IPFS. Create buffer call files add result. Okay. Details. Yeah, the issue availability is open IPFS in and itself does not do the work. It can be written on top. They are working on file content center. People uploading win by having people save return. Hosts win by receiving 5 coins. Yeah, I think for IPFS node. Let's get back to a topic of having it available after services are distributed. Poised to upload image as many as. So after image uploaded on one IPFS node, maybe the node uploads again to others, so therefore the same. To save it on the cloud platform. Then when accessing, yeah, then you can think of paid or better. Paid server is not really. But because it removes the need of one drawback that it requires user to have IPFS running locally. Yeah, we'll not know why or how to install this Chrome plugin, but yeah. So basically, that is a good learning. So one IPFS learning. Need a node running locally to have the image on IPFS network. Node down, image gone. Solution, service like Pinata, or have your node on all the time. That's a good one. Moralis नंतर बघता येईल आपल्याला. Create Moralis plugin. One way to solve is to modify localhost and host your own IPFS node. Means manage few servers, but at least you don't have a server processing images. But if your server turns off, the image becomes unavailable again. Yeah. So आपल्याला पिनाटाचं कॉस्टिंग बघायची आहे. पिनाटा प्राइसिंग. Pro plan 20 per month मध्ये AP access Pinata upload fast, one dedicated IPFS gateway Pinata submarine. Reach short 100 GB bandwidth include additional bandwidth and storage at 0.15 per GB. Okay, good. This is good. So $20 plan is okay. Or but that's pretty expensive. For small, let's see, unlimited storage म्हणतात ते 0.15 ला API not upload file manager. ठीक है, sounds reasonably okay with this. And what else? This is gone. This is not needed. Yeah, OpenSea वर टाकतो तेव्हा where does OpenSea store image after minting NFT? How do you store image? This OpenSea recently had new storing. Did you get the answer? Okay, so OpenSea decentralized NFT. There's about NFT since we launched. Okay. Today we are announcing the ability for decentralized using IPFS and Filecoin when creating. We are also providing to see decentralized versus frozen. Location of metadata, right? The value written by this function is the URL in Google or some sort of centralized and go offline. This is in contrast to decentralized, right? The concept of frozenness is distinct from centralized even when they are stored in decentralized manner. It's often still possible for the creator to make a transaction and change the metadata. We call NFTs that have unchanged or metadata frozen. Frozen centralized. Verifiable. Yeah, so frozen means data cannot be changed, but take that's we didn't get the answer here. And this was a good, this was okay. So our questions, which is, let's put it at the bottom. ठीक है, हे दिस इज इम्पॉर्टंट, हे आरामात करता येईल. हे एक नेक्स्ट व्हिडिओमध्ये प्रोबॅबली आपण बघू. IPFS ला, हां, IPFS हाऊ टू हँडल, बेस्ट वे टू गो अबाउट IPFS Pinata. What's the best way? That is the real question. So that's the question. And pros and cons. Okay, and then after that probably we reach to this point of ERC 1155. Yeah, and properties तर आपण बघितल्यात की सेपरेट कशा करता येतात. How to use NFT as badge, that is like something. That is very important. How to unlock access to content on, uh, only by authenticating certain NFTs. There is access membership for recharge. NFTs as keys. How to manage authentication. Those methods NFT incorporate access explainer. Okay, yeah, alright. Robe, demon, crown, later एवढे बनवलेत 1 2 3 4 5 6 7 8 9 1 2 3 4 5 6 7 8 हाँ बॅग नाही आहे. सो बेसिकली एका लूटची एक इमेज बनली. गॉट इट. Yeah, so loot is an interesting project which can go for this in here. Loot project. So this is the original NFT, or rather than this, let's say this is the original NFT. And this is like the creator economy, like somebody actually created an image out of that plain text of plain list of plain text of weapons. But our question is how to use NFT as badge, so that is still there. Use NFT to unlock content. Solidity for tutorial. Solidity tutorial. How to read, right? Yeah, that was, yeah, I mean, Ethereumचं स्वतःचा पण एक हे आहे. So how to read, write part 1 to 3. This is good. Connect Ethereum to create your app API key. Okay, this is testing साठी only, I think. ठीक है, and then create an Ethereum account, add Ether from faucet. ठीक है, हे सगळं. This is simple. Write our smart contract मध्ये इथे कॉन्ट्रॅक्ट पूर्ण दिलाय. So I think this is worth going through as well. So what we can do is go through official tut. ठीक है, and कनेक्ट मेटामास्क वगैरे वगैरे अल्केमीची गरज नाही पडणार. इथर कंपाईल राईट डिप्लॉय स्क्रिप्टमध्ये वेबसाईटवरून डिप्लॉय करता येईल. आय थिंक डिप्लॉय कॉन्ट्रॅक्ट हार्ड हॅट वापरलं जाणार. हार्ड हॅट इज आय थिंक जेसॉन बेस्ट असेल. Okay, in part 2 we'll actually interact with minting. Part 3 will show you how to view Ethereum wallet. ठीक है, how to mint an NFT, install Web3, grab your contract ABI, sorry, upload, create transaction. एक मिनिट. सो फर्स्ट मध्ये आपण काय केलं, कनेक्ट मेकॅनिक्स. अच्छा, राईट कॉन्ट्रॅक्ट लिहिला आपण. कॉन्ट्रॅक्ट लिहिल्यानंतर कंपाईल केला, डिप्लॉय केला आणि डिप्लॉयर कॉन्ट्रॅक्ट आणि कॉन्ट्रॅक्ट डिप्लॉय केला आपण पहिल्यामध्ये. सो दुसऱ्यामध्ये आपण काय करतोय, पार्ट 2 मध्ये आपण इन्स्टॉल Web3, कन्फिगर मेटाडेटा, क्रिएट इन्स्टन्स, अपलोड, क्रिएट ॲक्च्युली मिंट करतोय. पण आपण पहिलाच मिंट का नाही केली? ओके, हां, आपण फक्त कॉन्ट्रॅक्ट डिप्लॉय केला आहे. आता इथे आपल्याला मेटाडेटा करावा लागेल. ओके, या सो मेटाडेटा आपण जे स्क्रिप्टमधून टाकतोय. कन्फिगर मेटाडेटा युजिंग, ठीक आहे, पिनाटावरून अपलोड केला. या सो बेसिकली इफ यू रिमेंबर mint context and token URI, that should result to JSON, which is NFT, which is what really brings NFT to the life, right? So we'll use Pinata to store NFT asset and metadata. Once you have created files, upload image. After you upload, you see file, gateway, you can find image. And now we want to upload more. Before you need to create it, so आपण इथे create केले. Once you're done with editing, feel free to change. आणि इथे पिनाटाचं ते टाकलं image. Once you're done with editing, upload it. Following steps: uploading, create instance to your contract. ठीक आहे. ओके, आता आपण मिंट करताना सेपरेटली ती जेसन फाईल मिंट करतोय आपण ॲक्च्युली. सो कॉन्ट्रॅक्ट ॲड्रेस, नाव विल यूज अ कॉन्ट्रॅक्ट टू क्रिएट कॉन्ट्रॅक्ट अँड मिंट. अपडेट युअर ENV फाईल. ठीक आहे. क्रिएट युअर ट्रान्झॅक्शन. Let's define a function name mint NFT and create transaction. Sign the transaction. Send signed transaction will give us transaction hash. Call mint NFT and run node. Your code should look like this. Okay, I just don't like JavaScript, but what to do now? You gotta learn this stuff, man. Anyway, this part 3, how to view. Okay, set network, props 10, collective, MetaMask, and that's it. This is pretty easy. Unlockable content, how to unlock it is the question. कोणी काही दिलं नाही वाटतं. So this is also fine. Ultimate NFT programming tutorial. This is on Morales, I think. Let's see. Beta programming. We'll see. Yeah, next.js. What the fuck is it? Practical introduction to NFT. No man, that we don't want.
Welcome back to the Morales channel, everyone.
Morales.
That specific NFT. These after each other. The user
Why
is
is
signed in.
Morales? Main.js.
And
This is fucking. I just don't like JavaScript, man. It's it's not beautiful. That is it. Okay, so anyway, I'm not very enthused about Morales as such. Let's not look into it. How to create NFT with Solidity. I mean, like mostly तर आता आपल्याला कळलंय. सो रिमिक्स वरून तर आपण स्वतः आपला कॉन्ट्रॅक्ट एका तासाच्या आत तर लिहू शकतो. आय मीन विल रीड दॅट कोड while going through the code. I mean, while writing the code, we'll go through each of these functions. So we can do it on the fly. That's not a problem. Like that's really not a problem. And yeah. So then the question really becomes like, what hard hat is the check real quick? Is it JavaScript or what? Interactive. Hard hat industry standard. Create an hard hat. Let's see. Ethereum development environment. Hard कोणत्या language मध्ये run solidity locally. Okay. Extreme sensitivity fully plugin. ठीक है. I think we'll just learn hard hat. Is next generation. We'll learn hard hat. So we will do some tutorial. Maybe later on, but writing waffle hard hat, write coding to follow the tutorial. You should be able to write code in fucking JavaScript, man. That just sucks. Hard hat versus brownie. Truffle and hard hat both use truffle has been around for a while, but there is which is hard hat. Third one which is hard hat great documentation. I am going to follow the documentation as it is and will replicate. ठीक है, that is truffle. Let's install truffle. Let's try to run completely my thing. It's really completely different, but trust me, our content is quite similar. Okay, I mean, I'm just doing the brief introduction. No, there's no comparison. Let's just see why people would prefer hard hat. We should have to use and give us some insight which is the best to ramp on long term. I know Python best, but also know JS and TS bit. We have to ramp on JS TS again. I'm looking for which is going to be the best framework. I love Truffle. I'm sure there are others. I'm way more comfortable with Python. And JS is there in downside to Brownie. Currently using Brownie, loving it. The Brownie console is great. Yeah, man, Python all this. To build a website anyway, we need like React and some JavaScript. I mean, to build a front end, it's important. So one way to go about it is React वापरा front end ला and Hard वापरा management ला Solidity environment and JavaScript. The other is use Python Solidity code, interacting with Solidity, and use Bootstrap for front. So yes, yeah, let's try this. Alright, okay. npm install say okay, we'll create sample npx file. This will prompt this is left for simple, yes, simple. So yeah, and then this will create a bunch of files. The contract will scripts folder gives the code that deploys and the test folder is greater. Okay, it's a actual code. Notice that string constructor console.log. There is also written that something will not get in trouble. Yeah, I mean, but I don't want that. There is the code there that is fine to deploy a contract. Okay, so yeah, trouble. I'll use trouble unit migrations over that. Brownie. I think Brownie would be very convenient because it's fucking Python, but React is very important and Node.js as well. Okay, once and for all, you gotta do React. Okay. That is understood now. What are today's final questions? Okay. So we know how to launch the website. React मध्ये आपल्याला mint button वगैरे ठेवावं लागेल and once so probably let's say आपल्याला जर 50 फोटोजचा NFT डिप्लॉय करायचं आहे की ज्याच्यामध्ये user can select तर आपण 50 JSON तयार करणार. Okay, so let's say let's just write practical use cases. Practical use case. It's not even use case. So practical steps, high level steps to launch these two types of NFT contracts, NFT collection. So first collection is steps to launch two types of NFT collection. So first is this that users can choose NFT and then mint specific one. So in this case, upload 50, 100 images and JSON to IPFS from Pinata and usual contract is usual contract. Yeah, to do मध्ये how to accommodate properties and rarity, that is one. Upload usual contract, usual 721 contract, uh, front end website to actually mint could be in Polygon Matic. And the second is uh, creating collection for our own, creating 1,000 collection for our own and transfer NFT to new people. So for that we have to one contract will mint all NFTs under his own account. But how? Yeah, that is a question. Like, yeah, so basically by setting max mint to 100 or 1,000, max mint variable, and then simply transfer NFT to the recipient's address. Yeah, that makes sense. That is pretty easy. That is pretty fucking easy. So for college and um, yeah, see 1155 for Restro, mint multiple copies, only owner. See, these are all transfers, like we want to give free, so whenever it comes to giving free NFT, I think you need to mint NFT on your own. That is a big understanding. Yeah, I mean it's simple, but it's good to know that if you want to gift an NFT, you mint it and you simply transfer it on OpenSea. But and transferring OpenSea will require fees on your end, but which is fine because you have minted it from your own contract. So you are bypassing the entire that bridging thing on OpenSea, which is really good. ठीक आहे. सो आणि इवन कॉलेजसाठी जर आपल्याला मिंट करायचं आहे, सो लेट्स से देर इज SP कॉलेज, तर आणि स्टुडंट्स असतील 500, पण स्टुडंट्स वाढत राहतील. सो आय थिंक अगेन ओनली ओनर शुड बी एबल टू मिंट इट, nobody else. So first of all, this is important. Mint, only owner should be able to mint, no one else. Transfer for free on OpenSea, and only owner should be able to mint, no one else. Transfer for free. ERC 1155 असेल का तो check, don't know, I mean check if ERC 1155 is useful here. Actually I don't think so, because 1155 is identical, but these ones will have their own name written on it, I think. Yeah, so and should be done beautifully. See if contract can mint as per a supplied Excel file and transfer them to the recipients automatically. Okay, these are some considerations, but for restaurants we don't need. For restaurant, no need of person name in on-chain. For college, it may be useful. Yeah, that student belongs to this college. That is good actually. Yeah, useful. And then how can we do it a bit? How can we be creative? It's an ID card. NFT acts as an ID card, but a different kind of ID card, and only people who have got that NFT. Or shall we just mint something for college and retro and generic? For college, it may be useful to have name, student name and college name on chain. For general or generic, it could be 1155 ERC 1155 of Mona Lisa or whatever. Got it. And then you can play along with it. Sounds good. All right, so this was a good stream. We'll see where to start from tomorrow. And yeah, this one was good. Bye bye.